Bertrand Russell, who lived from 1872 to 1970, was one of the most influential philosophers of the 20th century. He wanted to answer a single central question: could all of mathematics be derived from pure logic? He was not alone in this. The German philosopher and mathematician Gottlob Frege had already spent years trying to show that arithmetic could be reduced to logic, an idea called logicism. But Russell discovered a problem in Frege's system, now known as Russell's paradox. Frege had defined numbers in terms of sets, or collections of things. For example, the number 2 could be defined as the set of all pairs, such as hands, eyes, or shoes. Russell asked whether the set of all sets that are not members of themselves includes itself. If it does, then it should not, and if it does not, then it should. Either way, contradiction results. The same idea can be illustrated with what is called the barber paradox. Imagine a barber who shaves all and only those men who do not shave themselves. Does the barber shave himself? If he does, he should not, and if he does not, he should. The paradox arises either way. Russell's discovery showed that Frege's system allowed self-reference, which led to inconsistency. To prevent contradictions of this kind, Russell introduced his theory of types. In this theory, logical entities are arranged in a hierarchy or series of types so that expressions can refer only to entities of lower types and never to themselves. At the lowest level are individual things, above these are sets of individuals, above those sets of sets, and so on. No class can contain itself, just as one cannot have a folder that contains itself. Russell and his collaborator Alfred North Whitehead used this idea in their monumental 3-volume work Principia Mathematica, published between 1910 and 1913. Their aim was to rebuild mathematics on consistent logical foundations. Famously, after hundreds of pages of symbolic proof, they were able to derive the statement 1 + 1 = 2. Russell also made major contributions to the philosophy of language. He realized that many traditional problems in philosophy arise from the way ordinary language hides logical structure. One example is the sentence, "The present King of France is bald." Is this sentence true or false? It cannot be true because there is no King of France, but it cannot simply be false either, because that would imply that there is such a person who is not bald. To resolve this, Russell developed his theory of descriptions. He argued that phrases like "the present King of France" are not names, but descriptions that can be analysed into simpler logical parts. For example, "the brother of Charles II was deposed" can be expressed as 3 statements. There exists someone who was the brother of Charles II, there was only one such person, and that person was deposed. If all 3 parts are true, the whole statement is true. If any part fails, the statement is false. This analysis allows us to make sense of sentences that appear to refer to non-existent things without assuming that such things exist. For instance, "the round square does not exist" means only that nothing satisfies both conditions of being round and square. Russell's logical analysis was revolutionary. It showed that by revealing the structure behind ordinary sentences, philosophy could avoid confusion and uncover the logical form of our thoughts. He also helped to modernize logic itself. Before Frege and Russell, logic was largely Aristotelian, based on the subject-predicate form, statements such as "Socrates is wise." But relations like "Socrates is taller than Plato" do not fit that pattern. is taller than is not a property but a relation between two subjects. Russell demonstrated that logic must deal with such relations directly, and his work, together with Frege's, laid the foundation for modern predicate logic, which underpins both mathematics and computer science. Russell's influence extended far beyond technical logic. His theory of descriptions provided a precise tool for analysing language, his theory of types reshaped the foundations of mathematics, and his method of logical analysis helped to establish analytic philosophy, later developed by figures such as Ludwig Wittgenstein. Russell's paradox also led indirectly to later results that defined the limits of logic itself. In 1931, the Austrian logician Kurt Gödel proved his incompleteness theorems, showing that any consistent formal system capable of expressing arithmetic will contain statements that are true but cannot be proved within the system, and that no such system can demonstrate its own consistency. Gödel's result showed that the logicist's hope of grounding all mathematics in pure logic could never be fully realised. Logic and mathematics cannot serve as their own ultimate foundation. Any proof of one must rely on assumptions that lie outside the system. Even so, Russell's achievements remain immense. He clarified the structure of reasoning, showed how language can conceal logical form, and helped to transform philosophy into an analytic discipline grounded in clarity and precision. Though his logical system could not achieve the absolute certainty he sought, his work permanently changed how we understand mathematics, language, and the relation between them.